Hello, in this video we are going to learn about inverse trigonometric functions. Here we are going to learn three of them: inverse sine, inverse cosine, and inverse tangent. So we all know that the sine function, the input is a reference angle theta. Okay, so sine of the reference angle theta equal x. Then inverse sine of x equal the reference angle theta. So you can see right here that the input of our sine function become the output for our inverse sine. And then the output for our inverse sine become the output for our sine function become the input for our inverse sine. So you can see the domain and the range they interchange, right? So the domain for the sine function become the range for the inverse sine, and then the range for the sine function become the domain for the inverse sine. So look at the next one, inverse cosine. So if cosine of the reference angle theta equal x, then inverse cosine of x equal the reference angle theta. So again, the domain for the cosine become the range for the inverse cosine. The range for the cosine become the domain for the inverse cosine. Now let's look at the last one, inverse tangent. Inverse tangent. So if tangent of the reference angle theta equal x, then inverse tangent of x equal the reference angle theta. Again, the domain for the tangent become the range for the inverse tangent. The range for the tangent become the domain for the inverse tangent. Okay. And there are six inverse trig functions. Here we only look at three of them. So we only look at inverse sine, inverse cosine, and inverse tangent. Okay, so let's look at here. So we given this right triangle, and we given the side length. So we given two side lengths. We have the opposite with the reference angle theta is 12. We have the hypotenuse, which is the longest side, the side across the greatest angle, the right angle is 15.7. So we want to find the reference angle, the theta. So again, this has to be an acute angle. So what trig function should you use? Okay, so we are going to use the sine function. So by definition, sine of the angle theta is opposite over hypotenuse. Now we are going to substitute. So we substitute the opposite for 12, the hypotenuse for 15.7. We don't know the angle theta, so now we are going to find the angle theta. So to find the angle theta, we are going to use the inverse sine. So basically, you are going to take the inverse sine both sides. Okay, so on the left hand side, you will have inverse sine of theta. So the composition of the inverse sine and sine function, then that just give us the theta. Okay, so therefore on the left hand side give us theta. The right hand side be inverse sine of this given trig ratio opposite over hypotenuse here, and then put in your calculator, and the angle will be round to the nearest degree, be about 50 degrees. Okay, now it's your turn. Can you help us to find the angle, the reference angle theta here? And let's check the answer. So the answer will be 58 degrees. So again, here, what trig function did you use here? So this is the reference angle we need to find, and next to this is the adjacent. So 7 is the adjacent. So opposite with the reference angle theta is the opposite is the opposite. Okay. So now you can see that you have the opposite of adjacent. So you must use tangent. So tangent of the reference angle theta is opposite over adjacent. Now you want to go ahead and substitute what we know. So we only know the two sides. So we don't know the angle. So we just substitute the opposite for 11 and the adjacent for 7. And now the next step, to get the angle theta by itself, you want to take inverse tangent both sides. Okay, so think about on the left hand side, you will have inverse tangent, and then on the right hand side, you also have inverse tangent. Okay, so therefore the angle theta will be inverse tangent of 11 over 7, and put in your calculator. That will give you 58 degrees. Okay, so let's look at the next one. Here we only move on the real world example, and the concept we learn right here will be angle of elevation. So what does it mean to call an angle? That will be the angle of elevation. So here, if you look at this picture here, or this here, you can see right here. Let's say that you are here, which is at the foot of the mountain, and then you try to look, and then you try to get to the top of the mountain by a cable. Okay. So the height of the mountain is 1,200 feet, and we also given the angle. This angle right here, 20.75, is the angle of elevation. Why we say this is the angle of elevation? Because it's above your eye level. So think about you here, and then you look up. Okay. So how can we find the length of the cable? Okay. So in this right triangle, what do we know? We know the angle of elevation, which is the reference angle here, 20.75. We also know the opposites, and we want to find the hypotenuse. So when you use the sine function, sine of the reference angle theta is opposite over hypotenuse. Now we are going to substitute what we know. So we substitute the reference angle theta for 20.75. We substitute the opposite 1,200, and we substitute for the hypotenuse is d. Okay. Now we go ahead and solve for d. So to solve for d, the first thing we have to do is that we have to multiply both sides of the equation. So we will multiply the left side and the right side of the equation by d. And now you end up with d times sine of 20.75 degrees equal 1,200, but it's still not isolate the variable d yet. So the next step, we have to divide each side by sine of 20.75 degrees. So now you have d equal this number, the whole fraction here, and put in your calculator. So it will be about 3,387 feet. So that could be the length of the cable. So again, angle of elevation is this angle over here, 20.75, because since you are here at the step or at the foot of the mountain and you look up, so it above your eye level. Okay, so let's look at the next one. So this one we will look at the angle of depression. So in this case, a person on an airplane look down. Okay, so now this person on this airplane look down on the ground at an angle of depression. So 15 degrees is the angle of depression, and again, why it is? Because you can see right here that this angle is below the. So think about this line is the line of sine. Okay, so this line, so this angle is below the line of sight. So 15 degrees is the angle of depression. And now we want to we also give the altitude of this airline is 10,000 feet. So we want to find the distance, how far from that person to the point on the ground that person look at. Okay, so we want to find this distance right here, the x. So if you look at our right triangle, the x is our hypotenuse, and then we know. So the next step is that inside the right triangle, we don't know the angle yet. We don't know the acute angle yet. We only know the right angle. Okay, so we know x is the hypotenuse. So you need to find either one of these two acute angle. So you do have two options. You can find this acute angle, which you take 90 degrees minus 15, or you can find this acute angle easily because the two lines, they are parallel, and this is the third line. So this angle also 15 degrees. So there are more than one option to find one of the acute angle. Okay, so can you help us to find the hypotenuse, please? Okay, so the hypotenuse, or the length from that person on an airplane to the point on the ground, is 38,637 feet. So where did we get this one? So again, there are two ways to do it. So I'm go ahead and use this angle here. So again, two parallel lines. So the third line traversal inside. So therefore, this angle will be 15 degrees. So now you have the reference angle 15 degrees. So I can label this will be the opposite. So this will be the hypotenuse. Now we are going to use sine. So we do sine 15 degrees equal opposite 10,000 over the hypotenuse x. So the next step, we are going to multiply x to each side. So x times sine of 15 degrees equal 10,000. And then lastly, we will divide each side of the equation by sine of 15 degrees. And then when you put in your calculator, you don't have to put the degree notation, just put sine of 15. Okay, thank you so much for watching. Goodbye.